Assalamualaikum and hi. We are from Group 4, Electric Circuit 2, BEV10403. We'll present about the project that have given by lecturer. Before we go further, let me introduce our group member first. My name is Muhammad Syaifuddin bin Asli. We have Hanan here, Muhammad Hanan bin Abdul Samad, Muhammad Yusri Hafiz bin Yuslah, next Muhammad Alif Aiman bin Khairuddin, and last is Muhammad Syafiq Haikal bin Suradi. Introduction. In this project, we are using multi-sim software to find out the load voltage to compare with the manual calculation that have been calculated using 5 methods. First, nodal analysis. Second, mesh analysis. Third, superposition. Fourth, source transformation. And the last is Thevenin and Norton. Alright. Next, we go to the component that we have used in this circuit. We have AC voltage 1 here are connected series to capacitor 1, and we have AC voltage 2 here are connected series to inductor 1 and resistor 1, and we have R2, which is resistor 2, and capacitor 2 are connected parallel to V2 and V1. Alright, for at AC voltage 1, we have used 240 volt 50 Hz. For V2, we use 4 volt 50 Hz and the angle is 20. For capacitor 1, here 79.56 microfarad. For capacitor 2, here 159.15 microfarad. For resistor 1, we have 25 ohm, and for resistor 2, we have 12 ohm here. And last but not least, the inductor is 0.1114 Henry.
Okay, now I want to show to you how to read the current peak and voltage peak at the graph. First, we need to run the simulation first. Okay, at the moment you just pause back the simulation. Okay, when it already paused, you go to the graph and just scroll up until you can see the range a bit. Okay, now at the simulation, at the schematic, the voltage is negative 95.627 volt, and for the current is negative 1.331 ampere. So let's see the current peak first. For the current peak, the blue color at the graph, so just click at the blue color and we can see the current peak is 4.235 ampere, and for the green is a voltage peak. Click at the voltage peak. The voltage peak is 98.598 volt. So that's how to read the graph at the multi-sim simulation.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Syafiq Haikal bin Suradi. My matrix number is DE200055 and I'm from Group 4 Section 2. So today I would like to present about my part, which is to measure the voltage and current in the capacitor in the circuit. So firstly, this is our circuit, and then to measure the voltage and current, we have to put the voltmeter and ammeter to this circuit. So this is the positive probe of voltmeter, and then this is the negative probe of voltmeter, and then this is the ammeter. So we have to choose the voltmeter and ammeter at this section. and then we run it. So after that, we have to pause it and then go to the graph. We expand it, and then we have to choose the peak value of the graph to measure the value of voltage and current. So firstly, the green graph is the voltage value. So this is the value of voltage of capacitor, which is 164.03 volt. And then for the current, this is the value of current, which is 4.1131 ampere. So to compare with the manual calculation, so it's almost the same, which is the value of current is 4.11 ampere, and for the voltage 164.44 volt. So this is the ways to measure the current and voltmeter in capacitor. That's all for me. Thank you.
Okay, now we're going to find out on how to determine the voltage and the current that flows through the inductor. So this is our circuit, and we will only focus on the inductor. So this is our inductor side. The first thing that we need to do is we need to denote the voltage reader, which is the voltmeter, to its positive and negative probe of the inductor. So we choose here the voltage reader. We put it on the positive side of the voltage, and then we put the reference voltage, which is the negative side. And then after we settle it, we need to denote the current reader, which is ammeter, after the component. So we choose here the current reader, which is the ammeter, and put it after the component. So it is perfect here. After we denote the ammeter and voltmeter correctly, we run the simulator. And when we want to read the data, we can either pause or stop the simulation by click here. Okay, so the next one, when we want to collect the data or we want to read the data, we change the display into the grapher display. So here, as we can see, it is the sinusoid data of the current and voltage that across through the inductor. So to read the data, we need to zoom in, we need to modify it until we will get the perfect graph to read. So we need to zoom in. So we zoom in the graph until we get the perfect one, the perfect shape of the graph. After that, we pick the peak value of the graph and denote it as the current and voltage that across the inductor. So the green one, the green graph represent the voltage, while the blue dotted graph represent the current. So as you can see here, the peak value of the current is, which is 1.4066 ampere, is the value of the current that across the inductor, while the peak value of the green graph, which is 49.387 volt, we denote it as the voltage that across the inductor. So why we pick the peak value of the graph? Because it is the maximum value of the voltage and current in a cycle.
Next, to find the voltage drop across the load and the current flow through the load, which is the load is 12 ohm resistor and 159.15 microfarad capacitor. So we must put the voltage and current reader right here to find the value of the current and the voltage load. After that, we must simulate the circuit to get the domain graph to find the peak value. We know that the peak value of the graph is the value of the current and the voltage. Okay, first, the current load for the circuit given is 4.235 ampere for the current load, and the voltage load for the circuit is 99.105 volt is the voltage drop across the load, which is the resistor and the capacitor right here. In conclusion, the electric circuit can be solved by applying any techniques like nodal analysis, mesh analysis, superposition theorem, Thevenin theorem, and source transformation. By applying this analysis for the manual calculation to find the voltage drop across the load and the current flow through the load. In addition, simulation also can be used to calculate the current and the voltage load. All the techniques can be used to obtain the correct result. That's all from our group. Thank you.